Hey guys, welcome back. This video is going to demonstrate problems 9 and problem 10 on your exam 3 review. Uh, it's intended to serve as a recap of some of the concepts concerning sampling distribution. All right, so sampling distribution, central limit theorem, things like that. We're going to talk about what happens to the shape of a distribution, what happens to its center, what happens to its spread, when we start using a sampling distribution versus taking something one at a time from a population. All right, so we'll start here with problem number 9. We have a population distribution, which when we first look at it here, has no apparent shape. It's not symmetrical, it's not bell curved, it's not uniform. It is really just a jumbled mess of a distribution here. All right. But what we do know is that the mean is 36 and the standard deviation for the population is 2.4. Right, so if I were choosing something one at a time, it would be very difficult to determine the probability that it's greater than something or less than something because of the way that this population distribution is shaped. Right, so this is the beauty of the central limit theorem in that instead of taking one thing at a time, I can create a sampling distribution by taking multiple things at a time. So when we go over here to this part, what we're going to do is we're going to take 25 items from the population. We're going to calculate the mean of those 25 items, and then we place that data marker here, and we do this over and over again. We take 25 things, measure its mean, and we do that infinitely many times, a million times, 2 million times, whatever. All right, and as we do that, if we take a sample size of 25, the shape is going to start to normalize. All right, so this is actually pretty close to 30, so we might get something like, who knows, maybe it's got a couple of little hiccups here and there, but it's starting to normalize a little bit, right? So it's not going to be perfectly normal at this point, but it's going to be a lot more normal than what we had over here because we're taking 25 at a time instead of one at a time. Right, so the center for this sampling distribution, when we take 25 at a time, is still going to be 36. It's going to have the same mean as the population distribution. So I'm going to mark that with a 36. The other thing that happens when we create a sampling distribution is that the variance or the typical deviation away from the mean is going to reduce. Right? So it's actually going to be a lot smaller than 2.4. We can calculate exactly what it is by taking the population standard deviation and dividing it by the square root of the sample size. All right, so in our case, we're going to take 2.4 and we're going to divide it by the square root of 25. And if you put that into your calculator correctly, you should get a standard deviation of 0.48. So you see that the variation in the data between the population and the sampling distribution greatly reduces, which is another really nice thing about taking a sampling distribution, right? It's a lot more predictable, right? So we keep going on, right? So instead of taking a sample size of 25, we're going to take samples of size 35. And if you recall from the lesson, the magic number for our sampling distribution to perfectly normalize is at 30, right? So once we're at 30 or more, we should have a really nice normal distribution for our sampling distribution. So that's what I'm going to draw for my shape here. I'm going to draw a nice normal. Oh gosh, my pen messed up on me there. And we're going to draw a nice normal distribution. There we go. So now we are normal. And I'm going to have to recalculate my standard deviation for the sampling distribution here. So we're going to say 2.4 divided by the square root of 35 for this one. And again, because the sample size got bigger, the variation in my distribution is going to go down even further. It's going to be less than the 0.48 that we had before. It's actually going to be 0.406 now. Okay, so if we put that into the calculator correctly, you should get 0.406. All right, so key things to remember about the sampling distribution, right? We're not taking one at a time, we're taking multiple things at a time, calculating a mean and distributing the means from each of those samples. As the sample size increases, the shape is going to become normal, which is what you see in these three diagrams. It starts off a jumbled mess, starts to clean up a little bit, and then once we go past 30, it's going to be nice and normal. The other thing that happens, the standard deviation or the amount of variation in your distribution is going to go down. It's going to reduce. The mean stays the same no matter what. The population mean will always be the center of your sampling distribution as well. So that 36 will remain the center as you increase the sample size. All right, let's do it one more time. We'll take a look at another one down here. We start off with a population distribution that is clearly skewed to the left, right? It's got a skew left, the tail's on the left-hand side. So this has got a pretty big skew to it. It's not normal. This is if we were to take one at a time, we would not be able to use our normal CDF function on something like this. We have to be careful if we have a problem that doesn't tell us about the shape of the distribution and we're only taking one thing at a time or anything less than 30, we don't have a normal distribution. We can't use normal CDF for it. All right. So moving on, right? So we have now, instead of taking one at a time, we're going to take 15 things at a time. We're going to measure their mean and we're going to distribute those means along this axis, and it's going to create a new distribution, which we call the sampling distribution. All right. So if we take things 15 at a time, it's still going to be slightly skewed, but not as much. All right. So it might have a little bit more of a tail on this side, but it's still going to have more of a tail on the left. It's still going to be slightly skewed because we did not get above 30 here. All right, the center of this distribution is still going to be 2.75. And our standard deviation is going to have to be corrected. We're going to have to take 0.15 and divide it by the square root of the sample size, which is 15. And you should get a standard deviation for the sampling distribution of 0.039. All right, now in this last one, they went right to the magic number 30, so we should have a nice normal distribution. And also remember, you want to try and draw it a little bit skinnier. That's a horrible drawing of the sampling distribution there. And it's not my fault because I do not like this pen. There we go, grab my pen back, and I'm going to do the best I can. If I can't get it, you're just going to have to picture a nice normal distribution here. That's not bad. All right, so there we go. So now that is perfectly normal because we reached a sample size of 30 for our sampling distribution here, so we are good to go. The center of this thing is still going to be at 2.75, and all we have to do is correct our standard deviation. So we're going to take 0.15, we're going to divide it by the square root of 30, and I'm going to put that into my calculator to get 0.027. Okay, so again, one more time, sampling distributions, what the central limit theorem does is it allows us to take multiple things at a time, like 15 at a time, and when we do that, all right, the variation is going to decrease according to our formula, and it's going to normalize the shape of the distribution. All right, the mean will stay the same, and that's pretty much it. All right. The one thing that I will note, both of these examples did a sampling distribution for a mean. Okay. If we were doing this for a proportion, the correction for the standard deviation, right? So for a proportion, the correction for the standard deviation would be p times 1 minus p over n, all inside of a square root. So it's a different calculation than what you see here, right? So this is for a proportion. So you got to make sure that you know what population parameter you are dealing with. All right, guys, that's it for 9 and 10. Tune back in for more help if you need it. Good luck.